Hello everyone. In the previous video we have studied about trigonometric ratios, and in this video we'll see how trigonometry plays an important role in the life around us, how heights and distances are actually calculated using the trigonometric ratios. In this we would learn about the basic terms, and there are some set of examples too. So watch it carefully.
A chapter on applications of trigonometry. Chapter is heights and distances. So in this we are going to deal with many interesting problems, many interesting verbal questions, I would say. So to begin with, to deal with such questions, you must be aware of all the basic terms which you must know, which you must be aware of. So let us see what is the first one. Look at this. You observe an angle over here. What exactly it is? Suppose this line which is marked here, this is representing horizontal. This is horizontal line. We know it's a horizontal line and we call it ground. Over here it's ground. Suppose observer who is looking at any object, I am placing the object here. Suppose object is here. Now observer is here, object is on the top. If observer is viewing this object, then this line which connects the eye of observer to object is called line of sight. Okay, the line which connects the eye of observer to object is called line of sight, and this one is horizontal line. Okay, this is the basic. Now there are two types of angles formed. One is angle of elevation, another is angle of depression. Let us first see what is an angle of elevation. Let's take this same figure. Observer is here, object is on the top, observer has to raise his head, observer has to look up to the object. So the angle which is formed between the line of sight and the horizontal is called angle of elevation. Very important. Angle of elevation is formed when observer has to look up towards the object. Observer has to raise his head to watch or view the object. Okay, now look at this one. Object has come on the ground. Observer is on the top somewhere at certain height. Now in this, if observer is viewing this object, definitely this line which connects the eye of observer to object is line of sight. Line of sight. Now the angle is formed with line of sight and horizontal. Okay, now do you think the line of sight and this horizontal can form any sort of angle? Definitely, if there are two persons watching each other, then one person from here looking at the other, angle of elevation can be taken. This can be taken as angle of elevation. But our situation is slightly different. Observer is on the top, object is placed here. In this case, observer's eye, as observer has to lower down his head to look at the object, the angle formed between the line of sight and the horizontal. You see this dotted line, this represents horizontal line, and this horizontal line is definitely parallel to the ground. parallel to this baseline given. The angle formed by line of sight with the horizontal in this case is called angle of depression. This is angle of depression. Now you would just remember it by that when observer has to look up, then angle of elevation is formed. Okay, when observer has to look up, he is looking up, the angle formed between line of sight and the horizontal is called angle of elevation. And angle of depression, when would it be formed? When observer has to look down, then the angle formed with the horizontal. This is horizontal, this is the line of sight. So this angle was angle of depression. Okay, this is angle of depression. I'm sure this must be clear to everyone. Question number 2 from exercise 9.1, one of the most important questions, which says a tree broke due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degrees with it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. Dear students, look at this figure. This is a tree. If we consider from the top, now AC is taken as total height of tree. Due to storm, it broke from this point. So this point I have taken as B. AC is the total height of tree. B is a point from where the tree broke. When it would break, it would definitely fall down. It fell down and the top of the tree, that means our final position, the top of the tree fell something like this. Okay, you don't have to actually represent it in the figure. Simple rectilinear figure can even do. So the top touches the ground at point D. Now the angle where the top touches, this angle is 30 degrees. This angle is given 30 degrees. Also they say the distance between the foot of the tree, this is foot of tree, point C is foot of tree, this distance and where the top touches, this distance is 8 meters. We are asked to find the total height of tree. Total height of tree means we need length of AB and BC, and finally we would add both to get AC. So AC would be AB plus BC. But how would you find AB? AB is actually the part which is broken, and AB and BD are equal. AB is equal to BD. This is important. Okay, now let's deal with this right angle triangle. It is a right angle triangle since the tree touching the ground, the angle, this vertex C has got 90-degree angle. We can straight away apply the concept of T ratios. BCD is right angle triangle where angle D is 30 degree. Let's see in this triangle, in triangle BCD, if I take ratio of perpendicular and base, I am taking BC by CD. What would be BC by CD? Angle is here, BC is perpendicular, CD is base. What is P by B? P by B is tan theta. So this is tan 30 degrees. BC is unknown, it's that broken, it's that part of the tree which is still standing firmly. BC we are looking for. CD, what is the measure of CD? It's 8 meters. Tan 30, we know tan 30 is 1 by root 3. So the length of BC will be, bring this 8 here, 8 upon root 3 meters. One part, a portion of that total height is calculated, BC is found. Now we need the length of BD. For that, look for which T ratio can help us to find the length of BD. It can be either sin 30 or cos 30. With cos it would be easier because in cos we would be taking this side, which is base. Okay, so also I would be taking B by H. B by H is cos 30 degrees, cos theta, base, CD, hypot, BD, and it is cos 30. CD, the measure of CD is 8, BD is unknown, cos 30 is root 3 by 2. So simplifying this, it becomes, I'll just write it here, BD, this is 8 into 2, 16, this goes here, BD into root 3, or the length of BD becomes 16 upon root 3 meters. Okay, now BC is found, BD is found, add both to find the length of AC. So on adding both, so here we write BC plus BD. BC 8 by root 3, BD 16 by root 3, root 3 comes common, 8 plus 16 is 24, 24 by root 3, we can just rationalize it further, root 3 in numerator, root 3 in denominator, this becomes 24 root 3 upon complete 3, root 3 would make it complete 3, simplifying this, it is 8 root 3, therefore total height of tree is, total height of tree is 8 root 3 meters. So this is the answer, this is what we were looking for.
Let's take up next question. It is question number 6 from NCERT, exercise 9.1. It says, a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. The angle of elevation from his eyes to the top of the building increases from 30 degree to 60 degree as he walks towards the building. Find the distance he walked towards the building.
Question number 6. A boy 1.5 meter tall is standing at some distance from 30 meter tall building. Look at this. There's a boy. AB represents boy whose height is 1.5 meters. He is standing at some distance. We don't know what this distance is. He is standing at some distance from a building which has got its height 30 meters. So height of building 30 meters, height of boy is 1.5 meters. Then they say the angle of elevation from his eyes to the top of building increases. Angle of elevation, boy is here, his eyes are looking at the top of the building. Angle of elevation initially is 30 degree. Okay, then he walked some distance towards the building and the angle increases from 30, it has become 60. Okay, and then find the distance he walked towards the building. We just need to find the distance which he has walked. So what we need? We need the length or the distance BF. We need this distance BF. Okay, this is unknown. So let us begin by considering, first thing, total height is 30, AB is 1.5. Since these are perpendiculars, so AB and let this point is G. AB and GD must be equal. So if AB is 1.5, GD would be 1.5 and GC or CG, that would be 30 minus 1.5, which is 28.5 meters. So we would be taking this as 28.5 meters. Okay, inner length. Let us now, because when you deal with triangle CGA, even then you need this length CG, and for triangle CGE we would be taking length CG again. In triangle, we are taking triangle CGA. In this triangle CGA, I would be taking perpendicular by base P by B. CG upon AG is tan 30. CG, this is 28.5 upon AG. Tan 30 is 1 by root 3. So AG would be, this is multiplied, 28.5 into root 3. Keep it as such. This is in meters, okay? This total length is found. Now let's find length of EG. For that, we are now switching to triangle CGE. Here even it is CG upon EG equals to tan 60. CG is 28.5, EG is unknown, tan 60 is root 3. So EG would become, EG goes here, root 3 comes here. So this becomes 28.5 upon root 3. We can't keep this in this form. Let's rationalize it and make our task a little easier. This becomes 28.5 root 3 upon complete 3. Okay. We can further simplify this. Solving this, this is 9.5. 9.5 root 3 meters. Okay, AG and EG. AG minus EG would give you AE. And why are we looking for AE? Because AE and BF are equal. Since they are opposite sides, I would call it a rectangle only. If this is 90, this is 90. Perpendiculars, two perpendiculars falling on base are parallel. So this closed figure becomes a rectangle. AE is AG minus EG. 28.5 root 3 minus 9.5 root 3. Take root 3 common, subtract both. 28.5 minus 9.5. We know it is root 3 into 19 or 19 root 3 meters. So if this is 19 root 3 meters, BF, this length would also be, BF is also 19 root 3 meters. So this is the distance which the boy has walked towards the building.
Another important question, now this one is on angles of depression, very important concept. It says, as observed from the top of a 75-meter high lighthouse from the sea level, the angles of depression of two ships are 30 degrees and 45 degrees. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. Very important question.
from the top of the lighthouse, if it is observed that there are two ships, point C and point D are considered as the ships. Two ships are approaching towards the lighthouse. The angles of depression from the top, when this ship is observed, the angle of depression is 30 degree. Now listen, observe this carefully. We know angle of depression, how is it formed? It is formed with the horizontal and the line of sight. So AD is line of sight, AE is a horizontal. So this angle, I would call this angle, this is 30 degree, it is marked here. EAD is 30. Alright. So can I say even this angle would also be 30? Is this 30? Reason, AE is parallel to BD and AD is a transversal. Alternate interior angles are equal. Now why do we need these angles? Because ultimately we have to deal with right angle triangle. Triangle ABC and triangle ABD we need. For that, angles are required. So if this is 30, this angle would also be 30. Then the second, let's talk about the second ship. The second ship, the angle of depression, horizontal line of sight. The angle between the horizontal, this is horizontal, this is line of sight. So this angle is 45 degree. If this is 45, this angle over here would also be 45. We need to find the distance between both the ships. We just need this distance CD. CD is unknown. Quite simple. Let's begin. First of all, we'll take right angle triangle. This is 90. In triangle A, B, C, if I say AB by BC, AB perpendicular by base, most of the cases would be, we would be dealing with tan only. Okay, so just remember all the values, tan 30, tan 45, tan 60, tan 30, tan 30 we know is 1 by root 3, tan 60 root 3 and tan 45 is 1. So AB by BC is tan 45, AB is 75, BC is unknown, tan 45 is 1. So here we get our first value, tan 45 has given us 1, so BC becomes 75. BC is 75 meters. Okay, this much is 75. Then we would now take triangle ABD. In triangle ABD, it would be AB by BD, which is tan 30. AB is 75. BD is unknown, tan 30 is 1 by root 3. So BD becomes 75 into root 3. This is, BD is found. Now what are we looking for? We just need the length for CD. So CD would be BD minus BC. Put the value of BD. BD is found 75 root 3 minus 75. 75 comes common, it's root 3 minus 1 meters. That's the answer. Okay. In case you are asked to simplify it for cost or anything related, then root 3 needs to be replaced. Otherwise, you can leave the answer in this form. So 75 into root 3 minus 1 is the distance between both the ships. Remember kids, in question itself, if it is given root 3 is 1.73,
find the distance between the shapes. Okay, so you will get the clue that root 3 has to be replaced and it has to be further simplified, otherwise it can go like that.